Dear students, hope you are doing great at home. Today we are going to discuss on the topic soliton propagation through optical fiber. This is under the program of MSc Physics of 6th semester, and the title of this course is Laser and Nonlinear Optics. I am Dr. Ritu Bargohan, Assistant Professor of Physics, University of Science and Technology, Meghalaya. So, uh, our topic today is soliton. So the content of this discussion is what is soliton. Then we'll be discussing about the solitary waves, one soliton and two soliton, then historical development of the soliton propagation, and the physics of soliton, the categories, two categories of soliton, so temporal and spatial, and the solution of soliton. Okay, so first we need to know the definition of soliton. What is this? It sounds like photon, so its relation, its basic properties should be similar to photon. So let's see what is soliton. A soliton is a self-reinforcing solitary wave that maintains its shape while it travels at constant speed. Okay, now soliton is a wave which will be not disseminating its speed as well as is its shape. Okay, while propagating through any medium. So that is why this study of soliton become important, because it's not going to lose any it's mm, this person sorry as this soliton will not going to lose its shape as well as speed while propagating through any medium. So this can be having a potential application in non lot of uh, lot of the fields related to this optical propagation. Okay, what are the basic properties of it? First, permanent form. Permanent form means it shape will be preserved throughout its propagation, and localized within a region. It will be localized within a region. That means it supports the first part, permanent form. So during the propagation also, it will be not changing its neither its speed will be changing, neither its shape will be changing. Means the amplitude that it will be there while it will be produced, that amplitude it will be maintaining throughout the propagation till the end. So this we can have we can see that if you light up a torch, then uh, at the starting point of the torch, the intensity of the light will be very bright. But when you go away from the torch, then the intensity of the light will be reduced. So that is happening because the dispersion of the medium through which the light is propagating. Now the soliton is one thing which will be not this there will be no dispersion affecting on the propagation of light. So at the end of whatever distance you will be traveling, you will be seeing the same amplitude and same intensity of the light uh, as the its entry point. Okay, so that will be the soliton, and will be, let's go forward with it. uh, Solitary wave, one soliton. Solitary, as I said, solitons, since it sounds like photons, so it will be, say, having same property of a photon. So first it behaves like a particle. So when we call a particle, call it a particle, that will be definitely, that will be quantized. So the energy of this particle, I mean soliton, should be quantized. So it travels with constant shape and velocity. So let's see one photon, one soliton solution. This is the solution of one soliton. So you can see here, you can see here that the soliton is going with a constant speed, so its speed is not changing, and you can see the shape means the intensity of it is not changing throughout the propagation distance. So this is what is called soliton, and we call it as one soliton. There will be several soliton which will be propagating in the medium, and though there will be interaction between these solitons, but they will be not changing their properties. These two property, preserving of shape and constant of his constant velocity, will be same for each soliton, whether uh, it will be communicating with others, or interacting with others, or something else. They will be maintaining these two qualities, these two properties, whatever the situation is. Let's see what will happen in if two solitons will be propagating in the medium. Solitary wave for two soliton. When two solitary waves get closer, they gradually deforms. Okay, so finally merge into a single wave packet. Okay, so this packet soon splits into two solitary waves with the same shape and velocity before collision. So though during the collision period, these two solitons will be deforming, and they will be converting to a one particular wave, but they will be uh, they will be separated after the collision, and they will be regain their original shape and the velocity as they were having before. So there is a demo here. Here you can see there are two soliton propagating from a negative x to positive x, and these two solitons are having different amplitudes and speed. Here you can see this is one soliton which is having a very low speed, and this is another soliton whose intensity is high, and also the velocity is high. Here another this soliton having intensity low as well as velocity low. So when these two solitons are interacting, say for example at this point they are interacting, after the interaction also they are separated as there was nothing between them. Okay, so this is what we call collision between two solitons. Okay, this happens in several type of solitons. If there are multiple collision of between collision between multiple solitons, they are not going to deform their shape or their speed. So these solitons are very interesting topic to study, and there are various applications in optics. Okay, so uh, let me tell you a story. I met Professor Z.D. Burwa in the IIT Dhanbad when I was doing my MSc, and he asked me what you are doing. Then I joined in BIT Mestra for my PhD. Then I said that I am trying to work on the topic soliton, something propagation of soliton in quantum wells. So he said, "Do you know what is soliton?" Then I said, "Yes, this is a say preserving wave that will be not going to reduce its speed as well as its intensity till its propagation distance." Then he said that see soliton, from soliton you can take the a beautiful example of life. So soliton when it travels, they do not take anyone's help, okay, to propagate. Okay, so even if there is another soliton propagating, it will be not taking the help. So if you have uh, problems in your life, then try to solve it by yourself. And if no one comes, if you have any problem there, and you call them, call your friends, and if no one is there, then try to solve the problem by yourself and advance go forward with the solutions. Okay, so he he uh, sing a song for me, and that song is যদি তোর ডাক শুনে কেউ না আসে তবে একলা চলবে. That is the definition of soliton also. Okay, which that we are forwarding, moving ahead. Yes, this is the discovery of soliton. The soliton was discovered by John Scott Russell in Scotland. What happens there? uh, Here, this is the story. Once John Scott Russell in 1834 was riding a horse along a narrow and shallow canal. Canal spelling is wrong. In Scotland, when he observed a rounded, smooth, well-defined heap of water propagating without change of the form or diminution of the speed. So, what he did, so there was a heap. This is the, say for example, this is the heap which is going forward. Then what he what he did, he ride on this horse in his horse, on his horse, and and go forward to this heap up to see up to what distance the heap will be. This heap will be not changing its shape and speed. So he have seen that to the destination of heap, this this canal touches the sea. So till the wave touches the sea, this heap was not disseminating its speed as well as its shape. So he then wrote uh, an article on it and published as a report on waves in the report of 14th meeting of this association for advancement of science. And that was the that was uh, what is what we should say, that was a the milestone in this discovery, in this study of optics. Okay, study of solitons. Okay, I'm giving you a demonstration of solitary waves. This is here, you can see it. Is it running? So it is not running. Let me show you separately. Yes. Oh yes, it is running. Same thing was happening there with Russell. Here you see the shape is preserved, the speed is preserved, and it is propagating. Okay, so this is the case with soliton. So soliton, when there is a soliton propagation, so it will be not changing its speed as well as its shape. Okay, the next part will be continued with the next video. Thank you. Up to here, we'll be meeting in the next video.